To factor by grouping, you're usually given four terms, and what you do is you group the first two together, and you pull out the GCF on those two. Now, I'm looking at that, and I see they're both divisible by x, so I will divide that out. That leaves behind 2x plus 3. Now, on the second half, we need to pull out the greatest common factor. And it looks like they're both divisible by 7, but you'll see here in a second why. I'm going to pull out a negative 7. And I get 2x plus 3 left over. Now, do you notice that they both have 2x plus 3 in them? Well, let's think about a similar problem, 2y minus 7y. If I asked you to factor the GCF out of that, what would you do? You would say, well, they're both divisible by y, and you'd write it out front, and then you'd put a parenthesis, and you write what's left behind. And what's left behind here is the x and the negative 7. So I could go ahead and put that in here, x minus 7. So up above, back up here, what did we say they have in common? They both have this 2x plus 3. That's a little bit like the y down below. So what do we do? We take that thing and we write it out front. 2x plus 3. Okay, 2x plus 3, just like we wrote the y out front down below. Now, what do we put inside the second set of parentheses? Now, just like we did down below, we had x minus 7 left over. We have x minus 7 left over here. So we put x minus 7 in there. So we just factored by grouping, and it's a process that's used when you're reverse foiling and or maybe just factoring by grouping, and you want to split it into two binomials. So let's look at another example. Again, we have four terms, and we think this thing might factor. So what we do is we take a look at the first two, and we just take the GCF out of those first two. It looks like they're both divisible by 5 and x. What's left behind would be 3x plus 5. You see how if we were to do our distributive property here, we would get these two terms right back. Now, let's look at the second two here. These two, what are they both divisible by? Well, nothing, right? 1. But do you notice how their signs are the opposite of this guy right here? So we'll do a little trick. Let's factor out a negative 1, and that leaves behind 3x plus 5. Oh my goodness, look at that. Now they match, which is exactly what we want. Remember that previous problem? We now take that 3x plus 5, it's called a common binomial. We write it out front, and then we attach it by multiplication to the remaining two things, which was 5x and minus 1. So there's the answer. We reversed foiled using the factor by grouping method. One more example queued up here. Oh my goodness, look at this. What a mess. But let's just dig into it. We look at those first two terms. They're both divisible by 2, and I see they both have an x, and I see they both have a y. So let's go ahead and factor that out, and that leaves behind 4y plus 7. Okay, well, that wasn't so bad. Now we're looking for a 4y plus 7 on the second group, and I see they're both negative, so let's factor a negative sign out. That'll turn them both positive, and I see they're both divisible by 3x. That leaves behind 4y plus 7. There it is. You see how they match? 4y plus 7, 4y plus 7. So we write it down, 4y plus 7 times the remaining two terms, which was 2xy minus 3x. Boy, a really crazy answer, sort of a weird FOIL question, but this was the reverse FOIL using the factor by grouping method. All right, hopefully this helped you out, and until next time.